The independent t-test analysis on SPSS. The independent t-test is a parametric test which measures the difference between two means, that is between two groups. The number of variables needed here are two. We have one dependent variable which is categorical, is dichotomous, and measured on a nominal scale. Example, gender at two levels, males and females. And then you can have one dependent variable which is continuous and measured at interval scale. The data set is drawn from the same population. Assuming a study, a researcher is interested in comparing mean scores between males and females and wants to test an hypothesis, a null hypothesis, which states that there is no significant difference between the mean scores of males and the mean scores of females. Already I have a data set assumed on Excel which I want to import to the SPSS user interface. I named it independent variable data. It's going to import to this SPSS interface in independent, that's the name of the sheet. Okay. Should give me, oh, this is the data view. The data view has gender and the scores, gender and corresponding scores. This gender has been coded, but I will show you on the variable view how it's done. You need to assign values to males and females. To assign value, you go to values, you assign 1 to males, right, and then 2 to females. Right. Okay, I've assigned values. Now I'm ready. I want to be sure that my measurements for the independent variable is normal, and then for scores it's on scale. Then I'm ready to analyze. I go to compare means, independent t-tests, independent t-tests. My test variables are the scores, and then gender to the grouping variable which should be defined, 1 for males and 2 for females. Continue. I check my option to ensure that I have 95% confidence interval. Continue, and then OK. The SPSS has analyzed this for me. I have two tables, one for the group statistics and the other for the independent sample tests. The summary of these are shown on the two tables. On the table showing the group statistic, it shows the means of males and females. The mean scores for males, for the male group, is 150.11. The number of males are 9, with a corresponding standard deviation of 11.624. Same for females. Number of females are 11, with a corresponding mean of 144 and standard deviation of 25. This indicates that the mean scores of males are higher than the mean scores of females. Furthermore, the independent sample test table also shows the values of the Leibniz test for equality of variance, which has the F ratio and its significance, the T value, the degree of freedom, and two-tailed significance, and then the boundaries of the confidence interval. The two-tailed test is significant at 0.51, which is more than the p-value of 0.05, indicating a statistical difference between means of these genders. There's a statistical difference between the means of males and females. In conclusion, a researcher might say, since the table value p is more than the assumed value, we therefore conclude by rejecting the null hypothesis, upholding the alternative, that is, the mean scores is not equal, the means of male scores is not equal to the means of female scores. Thank you.